This is a Flexis system. It was developed for system integrators. It is a 1 kilowatt fuel cell stack integrated with liquid cooling and also its own control electronics. This system was basically developed for research institutions, early adopters, and also potential clients that would like to test the state-of-the-art high-temperature PEM fuel cell technology. These fuel cell can operate between a range of 700 to 1800 watts, depending on what the customer wants. And we also develop a telematic system where you can monitor and control the system remotely. The water-cooled system allows the system to recuperate the heat, so you have the option either to recuperate the heat that the fuel cell generates, or if you don't need it, you just dump it out to the atmosphere. Pretty much right here we have the fuel cell stack, and in the back you have all the liquid cooling system. And it can be integrated with reform fuels, any reform fuel, and it also operates with hydrogen. This is the micro CHP unit. It's a 3 kilowatt unit, and we named it Pachito. EnerFuel developed the second of its kind. This particular unit integrates a high temperature PEM fuel cell on one side and a reformer, a propane reformer on the other side. We decided to scale up the fuel cell stack from 1 kilowatt to up to 4 kilowatts. Now, this system also has 4 batteries on the bottom, which will get recharged from the fuel cell power. And as you can see in the bottom, we have 2 propane lines. So you basically just fit 2 propane lines into the 2 propane lines into the system, one for a burner on this side, which will heat up the fuel cell, and the other one will provide the propane to the fuel processor to convert it into hydrogen. So basically this unit, it will be positioned in homes, and in this particular one we were not recuperating the heat. The total efficiency of this system was approximately from 36 to 38%, and it was demonstrated earlier in 2013.
So the Pachito 2 incorporates telematics, which means that it can be started with the push of a button remotely through wireless technology that we developed in-house. It also includes full battery system and is designed to run whenever there is a load that needs to be powered. It's basically hooked up to propane, and when it's on, it can toggle between standby and full power mode to maintain the state of charge of the battery bank. It's providing 120 volts AC power, and some of the unique features of the Pachito 2 are the small size, considering that it's a completely self-contained system, as well as it's water neutral, means that all of the steam that is used for the reformation of propane is recaptured in the system. So it actually doesn't need any water input into the system. So all the heat exchangers are in place to capture the heat from the product streams and return that energy to the reformer. The stack does a great job of facilitating this because it actually can use any fluid as a coolant. So we actually use 2 DI water streams to cool the stack. One returns heat to the reformer, and the other takes heat to the secondary heat exchange system, which can be used to provide hot water for the home or any other hot water need. And in the next generation, we take that a step further, and we use the heat to provide refrigeration, so further increasing the efficiency of the system. This is EnerFuel's Run Room 2, which is the large test station. Here we test reformers and large fuel cells, anywhere from 1 to 10 kilowatt fuel cells. reformers, and integrated systems. This room was built back in the 1990s to provide testing for 65 kilowatt fuel cell systems for automotive with a lot of funding from the Department of Energy. And over the years, we've just basically transitioned to high temperature fuel cell stack testing, subsystems like thermal management testing, reformer testing, and actually complete system testing. So the room has full ventilation to run reformer-based systems to remove carbon monoxide or any impurities that could be in the exhaust streams. And we also have a large 10 kilowatt test station for testing fuel cells that was built by some of the former Teledyne employees who are actually EnerFuel employees, built and designed and built this test station. You can see the Teledyne logo, and this station was purchased by EnerFuel back in 2006. This is the third generation of reformer that is going to be used in the Pachito 3 3 kilowatt micro CHP system. Some of the changes between the second generation and the third generation are that this reformer includes a startup burner integrated within it. Previously, EnerFuel created our own startup burner, and the idea is that the startup burner uses propane to heat up the fuel cell to a reasonable temperature so that we can begin pulling electric current. In this case, the startup burner is integrated into the reformer, so we realized a significant space savings by doing that through working with our reformer partner. This is the reformer test station, and here's where we test reformers when they come in. We've done all the electronics, PLC-based microelectronics, which can operate the components, the blowers, heaters. We vaporize deionized water and provide that feed stream to the reformer, and we monitor the quality of the reformate gas that's produced. So we do a quick checkout of the reformer prior to system integration. We're back in the test room. This is the large test station, which was built by a lot of the employees here at EnerFuel back when we were part of Teledyne. So it's a Teledyne 10 kilowatt test station behind me. And here we have the EnerFuel 3 kilowatt stack. This is high temperature, 132 cells, BASF MEAs. This stack produces 3 kilowatts of electricity at greater than 50% electrical efficiency. What I have here is the thermal management system, and this is something that we also built in-house. It comprises a radiator, a DI water tank, a heater, microcontrollers, so a micro pump, pressure regulator. The purpose of this system is to heat and cool the fuel cell stack and to maintain the proper operating temperature of the stack. It's a two-phase cooling system, so basically the DI water is vaporized and provided as steam to heat up the stack very rapidly, so in about 15 minutes or less. And then when we want to cool the stack, we're removing the heat from the stack by vaporizing that fluid at elevated pressure. And this approach gives us a very uniform temperature within the stack. Inside this jacket is all of the thermal insulation, and we're able to maintain plus or minus 5 degrees to 7 degrees C across any cell in the stack, which is it's a very difficult challenge for most people in high temperature fuel cells, but the membranes respond the best when temperatures are almost perfectly uniform. So the cooling system and the stack combined together give us some of the best temperature regulation in the industry in the high temperature space.